Hi everyone, we're going to do Module 12, Section 5 today on proving segment relationships. We've been talking a lot about proofs, and today we're going to take a look at some proofs involving line segments. Now remember, we did an entire module on lines and line segments, and we learned a lot of postulates and theorems and definitions and rules. Those are good reasons to use in a proof. So I'm going to remind you of some of the things we learned earlier and talk about some good reasons you might use in a proof about line segments. So number one, we learned what was called the segment addition postulate. And the segment addition postulate is for a picture like you see there. And it says if you have one line segment kind of broken up into two pieces, or if you remember our book the first time through called it the betweenness of points property. If you have a line segment with a point in between the endpoints, it creates this situation. Now, notation-wise, remember, when you see this little M right here in front of any of these line segments, that means the measure of. So all of a sudden this is saying the measure of line segment AB, which means if I took a ruler and measured this piece right here, plus the measure of line segment BC, if I took that same ruler and measured this piece here, would end up equaling the measure of AC from here to here. And again, that's obvious. That's why it's a postulate. Remember, theorems can be a little bit complex. Postulates are usually simple and obvious. So remember, I mentioned a minute ago, if you put that little M in front of a line segment, it means the measure of. And with line segments, there's another way to do the same thing. If I put the letters without the little line segment symbol on top of it, that also means the measure of. So that thing down at the bottom that you're looking at right here, where it just says AB plus BC equals AC, that's actually the exact same thing as this up here. I can say it as the measure of the line segment. That takes a little bit more writing. Or I can just say the letters without the little line segment and it means the exact same thing. So remember, I've been telling you ever since we started geometry, a big part of geometry is understanding the vocabulary and the notation and knowing what you're seeing. Okay, here's another good rule for line segments. It's the definition of congruence. And remember, congruence is when two shapes are exactly the same. So the definition of congruence says, number one, these two line segments are congruent. AB is congruent to CD. If and only if. Now remember, that's our biconditional statement, so this one works forwards or backwards. And then you have the measure of AB equal to the measure of CD. So what it's saying is congruence and equal measures are the same. If two segments are congruent and you measured them, you're going to get the same number. Or backwards. If you measure two line segments and you get the same length, then the line segments are congruent. So this is a biconditional statement. It works both forwards and backwards. It's saying if the measures are equal, then the segments are congruent, or backwards. If the segments are congruent, then the measures are equal. Here's another good one we learned a couple modules ago. The definition of midpoint. So midpoint means, it's kind of like middle point, and it means the exact center. So this is not the segment addition postulate. This is not any point in between A and B. This is the point exactly halfway in between A and B. So what it says is, if M is the midpoint of AB, then AM is congruent to MB. And remember, the way we mark that with line segments is like this. So if I put those two little red markers on there, then I'm showing that AM is congruent to MB. And if I wanted to say that in a proof, my reason would be the definition of midpoint. Our book actually calls this the midpoint theorem. I'd accept either one. And one thing about proofs, I'm not super picky on the wording of the reason as long as you get the concept right. So for example, if you were trying to say in this picture that AM is congruent to MB and you said definition of midpoint, midpoint theorem, even if you just worded it yourself, it said because M is the midpoint, basically if I see the word midpoint anywhere in your reason, you're getting full credit for that. So you just need to show me when you're giving me a reason, you need to show me how you knew that in this case AM is congruent to MB, and it had something to do with the midpoint. Here's some other reasons for proofs. Number one, the first reason of pretty much every proof is given. So there's given information in a proof, you copy it down, reason, given. And what you're saying is, remember, when you're doing a reason for a proof, imagine me asking you, how did you know that? So if you copy down what was given in the question, and I say, how did you know that? You could say, it was given in the question. Well, instead of writing out the whole word, the whole sentence, it was given in the question, we just put the word given. Now I added on here, prove is never a reason. This is something people do all the time. It's just not a reason. And I mean, if you think about it the same way I described it the first time, if I ask you, how did you know that? And you said prove, that's not an answer to that question. I would look at you kind of funny and say, what do you mean prove? I asked you a question, how did you know that? So given can be a reason. You're saying, yeah, that was given. That's how I knew it. Prove, not a reason. You can use anything we've learned before. So remember, we did our algebraic proofs. You can use all those properties: addition, subtraction, multiplication, division, substitution, distributive property, transitive property. I told you we're going to use transitive property a lot. This is a big one here. Remember the transitive property. We'll definitely use that one a lot. So right here, for our example today, you're going to see your first true proof. Now, a proof has definitely two parts, usually three. The things it definitely has are, number one, some given information. You have to have something to start your proof with. Then, number two, something to prove. So those two things are in every proof. Now, usually, a proof has a picture that goes with it too. There are proofs that don't need a picture, and there are proofs where you need to draw the picture yourself. But usually, for most of the proofs we're going to do, you're going to have given, prove, and then a picture. So let's do it. It says given AB and CD bisect each other at point M, line segments AB and CD bisect at point M, and BM is congruent to CM. Prove that AB equals AM plus DM. Now, eventually, I'm just going to give you this proof and say ready, go. But like I said, we're not quite ready for that. I don't want to do that to you yet. So what I did is I worked out the proof myself. And then I kind of erased parts of my proof to create sort of a fill in the blank for you guys. So that's what we're going to do. Instead of you having to create the entire proof just from scratch by yourself, we're going to practice where, I gave you some of the statements and you're going to provide the reason. In one case, I gave you the reason. You need to figure out what that statement is that goes with that reason. All right, so starting at the beginning, the number one statement and the number one reason are pretty much an automatic. In fact, actually, when I created this slide, I literally just copied and pasted. I did a copy and paste. I took what was given, which is line segment AB and line segment CD bisect each other at point M, and BM is congruent to CM. And then for reason, it was given. I mean, that was given in the question. That's the reason. So that's free, but for everything else, you need a good reason. Let's go through and mark everything that we have in the picture. So AB and CD bisect each other. I can't really mark that, but I can mark that line segment BM is congruent to line segment CM. That was given in the information. So I marked up my picture. Now statement number two says line segment DM is congruent to line segment CM. So I say, okay, now how do I know that? I'm going to write on my picture for a second just so you can see what I'm thinking. I'll erase it when I'm done. But line segment DM is this one right here, and line segment CM is this one right here. So you think, based on what I know in the problem so far, how do I know that's true? Well, I know that's true because those line segments bisect each other. Bisect kind of means the same as midpoint. It means to cut exactly in half. So what I would say for my reason here is the definition of bisect. Now I use a lot of abbreviations, DEF for definition. That's fine, you can do that. And like I said, even if you didn't say definition, if you just say anything about the word bisect, or even if you said the word midpoint there, I would give you credit for that, because I know you knew that's how they were congruent. Okay, let's take those out. But let's mark up our picture. So I just said that dm is congruent to cm. Now cm already has one little marker on it, so let's just put the same one on dm. Okay, so let's look at step 3. bm is congruent to dm. Those are already marked congruent in my picture. See, bm is this one right here, and dm is this one right here. Those are marked congruent. So then the question is, how did they end up marked congruent? How do I know those two things are congruent? Well, what you have, if you look over here, bm is congruent to cm, dm is congruent to cm. So you have two different things that cm is congruent to. Remember I told you guys the transitive property is a very important one? This is transitive property. If you ever have two things that are congruent or equal to the same third thing, then those two things have to be equal to each other. So this is the transitive property. And I'll abbreviate again, PROP for property. But basically I'm saying if dm and bm are both congruent to cm, then they have to be congruent to each other. All right. Next step. Here's one we talked about in the notes today. To get from here to here, to get from step 3 to step 4, you look at it and you go, well, I don't get it. It says the exact same thing. It almost says the exact same thing. Step 3 says line segment BM is congruent to line segment DM. Step 4 says the measure of BM is congruent to the measure of DM. Now remember, I told you in the notes, this is one you want to remember. That's the definition of congruence. Anytime you have that picture, like my little green arrow shows there, if you have two things that almost look exactly the same, but one of them's about a shape and one of them's about a measure, and you're saying, well, if these things are congruent, these are equal, or if these are equal, these are congruent, then you're talking about the definition of congruence. Okay, on step 5, I switched it on you. Instead of giving you the statement and asked for the reason, I gave you the reason and asked for the statement. So the reason is segment addition postulate. Now, looking at my picture, I see two possible things we could be talking about here. The segment addition postulate could be built on this segment right here, where it could be CM plus MD equals CD, or it could be built on this one right here. It could be AM plus MB equals AB. So at this point, we actually don't know. So what I like to do, look one step down. In step 6, I'm talking about AB. So I think I'm going to do the green one. I think I'm going to do AB. So let's make it match so it looks almost like step 6. Segment addition postulate says AB equals, and then you add up the two segments. You have AM plus MB, or BM. Actually, let me write it as BM because that's what we have above. MB and BM are the same. It doesn't matter, but I'll make it match above. Okay, so we're one step away. Now remember when I said in a proof, you know, the first reason is always given, the last reason is never proved. People do this all the time. They look at the proof and they say, well, this was given and this says proof, so I'm going to write given here and I'm going to write proof there. Don't ever do that. The reason in a proof is never the word proof. You just need to ask yourself, how do I know that this is true? Well, let's look at how we got from step 5 to step 6. This is the same. This is the same. What's changing is I'm changing from BM to DM. Well, if you look at step 4, those things are equal. If two things are equal, you can change from one to the other. That's substitution, and that's our final reason. So your final reason here is the substitution property, or just substitution would be fine either. I'll put substitution property. But remember, what you're saying for step 6 is, how do I know that? You know, based on what's written in the steps above, how do I know that AB equals AM plus DM? You know that because it's exactly the same as step 5, but you substituted DM for BM, two things that you already showed were equal in step 4. So that's how a proof works, and that's what we're going to do for today. Very soon, you're going to be asked to write the whole proof yourself, but not yet today. Today we'll practice with the fill-in-the-blank proofs just to get used to it.